All right, guys, we're back again for Lussac's law. We took a look at Charles' law, and now we're taking a look at Lussac's law. But now we're going to assume volume is going to remain constant, and we're going to take a look to see what happens to our pressure when we change either our pressure, or we're going to take a look to see what happens to our temperature if we change our temperature. So now we are going to use P1, T1, and P2, T2, where P1 and T1 are your initial pressure and temperature, and then P2 and T2 are your final pressures and temperature. Just like we did with Charles' law, we want to make sure that we go ahead and convert our temperatures into Kelvin. So again, that's just adding 273.15 degrees to that. Making sure that all of our temperatures are always written in the same format. We haven't gotten into making sure everything is into atmospheres, but we want to start thinking about that as we get into the ideal and the combined gas laws. We'll have to have them all in standard temperature and pressure, which would be atmospheres, atmosphere and kelvins for there. So it may be a good habit to get into, but we're going to take a look at how does the pressure, how does the temperature change, assuming, again, we keep the volume constant. So if we have some gas, let's just say at 1 atmosphere, and it is heated from 20 degrees to 30 degrees, what would happen to its pressure? And so we're going to set it up. We have a gas at 1 atmosphere as our initial pressure. We have it at 20 degrees. We're going to heat that up to 30 degrees Celsius. And we want to know what is our new pressure when we do that. Just like we did again with the Charles law, if we take a look here, we want to make sure that we add our 273.15 to each one of these so that we can get these in the correct units of Kelvin. So our initial temperature is going to be 293.15 Kelvin. And now as we add these together, our final temperature is going to be 303.15 degree Kelvin. And so from here, since we're solving for P2, we can just cross multiply. We have our 1 atmosphere. And we're going to multiply that by our 303.15 degree Kelvin. And that is all going to be over our 293.15 Kelvin. And again, we were wondering what would the new pressure of the system be. And this is good because kelvins will cancel out. That leaves us in ATM or in atmospheres, which is what we use to measure pressure. So if we grab our calculator, 1 times 303.15 is going to be 3.303.15. So we just need to divide that by 293.15. Our new pressure should come out to roughly 1.03 ATM. And taking a look at that, as we look at our relationships between our pressure and our temperature, as our temperatures go up, our pressure should go up. As our temperatures go down, our pressure should go down. And we took our temperature from 20 degrees up to 30 degrees. So therefore, we saw an increase in temperature change. We should see an increase in our pressure change, albeit just a slight one. There was an increase in the pressure from there. Again, this is Lussac's law. Again, it's using the same principles, but now we have our volume being held constant, and we want to know what is the relationship between pressure and temperature as we change one or the other. Again, there's plenty of exercise problems, practice problems on our unit guide. Please use those. Just wanted to kind of remind everybody on how to do not only Charles' law in the previous video, but also Lussac's law here. So thank you.